The real massive energy source in our solar system, overwhelmingly, is the sun. Solar energy exceeds all other energy by a factor of 1 trillion, like literally.
In 2020, the International Energy Agency confirmed in its World Energy Outlook publication that electricity generated from solar panels was cheaper than that generated from coal and gas in most countries around the world. Nations and individuals have warmed up to the idea of using solar energy to meet their energy demands, with large-scale and individual solar installations seeing a sharp uptick in recent years. Switching energy sourcing from fossil fuels to solar energy could surely help reduce carbon emissions, but won't be the ultimate planet-saving move that many believed it would one day be. There are still many hurdles to overcome with this technology, including issues with panel manufacture and materials, the lifespan and waste generated, energy storage and transportation, and localized climate change possibilities. The question is, are we creating a green future, or are we creating future problems? The sun is a massive source of energy. The fusion of hydrogen atoms to form helium releases tremendous amounts of energy into space, a fraction of which is received by Earth. Estimates suggest that this fraction is about 174,000 terawatt-hours of energy, but around half of this, or roughly 83,000 terawatt-hours, actually hits the ground. In comparison, the global electricity consumption in 2022 was a little over 24,000 terawatt-hours. So, if we were to capture energy from all the sunlight that hits the ground, we would cover the world's electricity demand and have twofold as much spare. Another form of this thought experiment is to cover large deserts such as the Sahara with solar panels and use the electricity captured to power other parts of the world with clean, green energy. Solar energy solutions are ideal for solving our energy woes, but when one considers their practicality, the shortcomings of solar energy technology become apparent. On the face of it, solar panels are made from the second most abundant material on the planet, silicon. The popular semiconductor material makes up 27.7% of the world's crust by mass. However, silicon alone is not enough for solar panels to work. Electricity generated by solar panels needs to be conducted to the storage unit, a job done using conducting materials such as copper and silver. To make solar panels cost-effective, they need to be produced at a large scale, usually done by using technologies like thin-film photovoltaics. The production of thin-film solar cells requires rare metals like cadmium, tellurium, indium, and others. In contrast to silicon's wide availability, tellurium makes up only 0.0000001% of the Earth's crust. Large-scale production of solar panels requires larger amounts of cadmium and tellurium, which is not only an availability issue but also a geopolitical one. In 2011, prices of certain rare earth materials shot up by as much as 750% in a single year after China clamped down on their production. The Asian giant either produces or was involved in the processing and production of 97% of rare earth and minerals on the planet, and its policies have a direct impact on the production of clean energy technology. Much of the growth in the adoption of solar technology around the world has been fueled by the production capabilities of industries based in China. The clean energy industry has enjoyed government support in the form of subsidies and favorable policies, but that is now set for a major change after the Chinese government announced a new regulatory regime that will roll back subsidy loads and make the industry less profitable. This could push the prices of solar panels higher once again, making them less attractive to potential buyers. A policy change would not necessarily happen solely for economic reasons. China's dominance in manufacturing and technology development in recent years has boosted its ambitions on the global political stage. However, its tensions with the US have left the global supply chain on tenterhooks and at high risk of falling apart due to political moves. Large-scale plans to start solar energy farms anywhere in the world can come to a grinding halt if the supply of components from China stops abruptly. Even if the Chinese dominance in the supply chain were carefully mitigated, solar energy installation and usage comes with its own problems. Even after decades of technological development, solar panels' power conversion efficiency is around 25% at best. With large amounts of sunlight remaining untappable by technology, solar farms have no other option but to increase the scale of installation to generate large power output. Estimates from the Solar Energy Industry Association, or SEIA, suggest that it takes anywhere between 5 and 7 acres of land to generate just 1 megawatt of solar energy. Conservative estimates peg this number much higher to 10 acres. Other clean energy sources like wind turbines have a completely lower land use requirement. Moreover, the land remains available for other purposes such as residential or agricultural use. Countries with limited land availability find it difficult to adopt solar energy as a clean energy solution, with priority given to agriculture or industrial usage of available land. Even in areas where large parcels of land are available for solar energy installations, the energy generated from the power plant has limited applications. Photovoltaic panels convert solar energy into electricity, which can be used to power the grid. However, industrial applications such as high-temperature furnaces or long-haul transport cannot be powered by solar panels. Since solar is an intermittent source of energy, usually unavailable for at least half of the day, electricity produced during the brighter parts of the day needs to be stored somewhere to be used when the demand for electricity is high. Electrochemical batteries, which use chemicals like lead, have been used in the past, but as the size of solar plants has increased, batteries with higher energy storage capacity are in demand. Lithium-ion batteries are the best technological solution available for this, but they are also extremely expensive to deploy at large scales. Although solar energy might be effectively free to harvest, the initial setup of solar panels and energy storage solutions is expensive. This is the basic reason solar energy isn't being harvested in the world's deserts and shipped to the rest of the world. Let's examine this in more detail. Installing solar panels in deserts would eliminate all the land use issues associated with solar energy and extract energy from areas where the sun shines the most, quite literally. A typical photovoltaic panel installed in a solar farm produces 350 watts. Over 50 billion such panels would need to be manufactured to meet the world's energy demand. These 50 billion panels would cover an area of 115,625 square miles. Since the Sahara Desert alone has an area of over 3.6 million square miles, this whole experiment could be centralized there. Moving from the thought experiment to bringing this into reality, one begins to see the hurdles in getting this done. On average, installation costs for a 350-watt panel, along with the mounts and infrastructure, are about $700. Doing so in the Sahara would definitely cost a bit more. At a 50% premium, let's round it off at $1,000. Installing 50 billion panels at this price would balloon the project cost to $50 trillion, which is nearly 18 times the size of the US economy. But the project would be useless if it did not have the equivalently large battery pack connected to it. At current energy storage costs, that would be around $900 for each panel, practically doubling the cost of the project. That's over 30 times the size of the US economy. Even if we did manage to fund such a project, the energy generated would still need to be sent to different parts of the world, so there is the additional cost of building a global grid. But we also know sending electricity over the wires involves transmission losses. The further away from the Sahara the country is, the more energy it will lose by the time it receives its electricity supply, making it highly inefficient. Even if we were still to proceed with the plan, the presence of 50 billion panels over the desert would also cool the area. This would return rain to the area, likely increase vegetation, and cover the panels, prompting a shift in the location of such a power plant. If a mitigation strategy were put in place to avoid this, one inevitability remains. Solar panels eventually reach the end of their life cycle and need replacement. This brings us to the last part of our problem: disposing of solar panels. The uptick in solar installations might be good news for the planet in terms of preventing fossil fuel usage, but also spells impending doom a few years down the line. Taking into account that solar panels work for 3 decades before they need to be replaced, one presumption that the problem will become a major one by 2050 or thereabouts. Plenty of time to come up with a solution. However, commercial solar installations have been in place for well over 2 decades. According to estimates by the International Renewable Energy Agency, large amounts of solar panel waste will begin piling up as early as 2030. The peak of solar energy waste may be in the 2050s, but is expected to be a colossal 78 million tons. Imagine a pile of solar waste if 50 billion panels were installed in the Sahara. A Harvard Business Review report pointed out that IRENA's predictions assume that users will continue using their panels until the end of their lifespan before replacing them. However, improvements in energy conversion efficiency could prompt users to dump their panels earlier in favor of energy-efficient ones, bringing forward the problem of solar waste. The long life cycle of solar panels has discouraged investment in recycling. Even though panel production uses some expensive metals like silver and copper, these are present in very small amounts. Processes for their recovery are complex, require hazardous chemicals like strong acids, and increase the cost of recycling the panel. In comparison, sending the panel to a landfill is way cheaper. However, the sheer number of panels that will be at the end of their lives in the next decade makes this untenable. The presence of heavy metals like cadmium and lead in the panel also adds a layer of complexity to the disposal problem. All in all, turning to solar energy as the planet's ultimate energy solution is a massive mistake one could make. Right from production of the panels to their disposal, the solar energy is riddled with problems that magnify with increasing scale. However, future solutions to these problems cannot be discounted. From a cost standpoint at least, the $90 million Tesla-provided Hornsdale Power Reserve in South Australia paid for itself in 2.5 years and is currently making good profit. This is the largest battery plant in the world, which deals with the excessive power generation that's being pumped back into the grid from rooftop solar panels in the area. The initial cost, however, doesn't factor in the panels themselves, as these are privately owned. This was a program set up to manage issues with existing power infrastructure, rather than building an entirely new one, so cannot be compared to the Sahara concept one-to-one. It also doesn't address the waste, manufacture, or geopolitical issues associated with the tech either. Action is needed now to mitigate these issues, if we don't want a significant problem in the future. One could also argue that the problem isn't so much the technology we use as our hunger for more energy and more things. We want the same kind of growth that fossil fuels made possible, even though we are aware of the harm they have caused to the planet. As a civilization, we do not want to taper down our energy consumption or consumeristic attitudes, and in there lies the real problem.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching and see you in the next one.